That's this doesn't work. You need the charger. You see this shit? You need to mirror your screen. Yes. Oh, let's turn the lights up. You guys turn up the light. That's fine.
Yeah, well, I'm short, So I'm Max. I'm one of the co-founders of Docs, formerly known as Docmunch. We are a small bootstrap startup in San Francisco. There's 4 of us. Greg Weber, who a lot of you know, my partner Mike, and we have a guy, Sean Leather, who's remote in South Africa. So what is Docs? We are focused on document engagement and analytics, and initially what that means is we take PDFs, Word files, let people view them in the browser, and then tell the owner of those files analytics on those documents. So you can see who's reading your document, how far they're reading, etc. It's useful for content marketers, inbound marketers, etc. Of all the products that we worked on, we've had several pivots. This is the least sexy product area that we've even come close to considering, but it's also far and away the most marketable and has the most demand, so we're actually really happy about that. So, about our stack. Storage, we use MongoDB. It's easy, persistent. I'm sure a lot of you are familiar with that. Yesod, part of the Yesod persistent, part of the Yesod web framework. On the front end, because as law, you must use an alt.js. We use TypeScript, and AngularJS as a MVW, whatever that stands for, framework. So our application is very heavy on the client side. There's a lot of JavaScript that gets generated by TypeScript, and as we all know, we lose some of the warm and fuzzy type safety that Haskell brings us. So a little bit about TypeScript. TypeScript is a typed superset of JavaScript. It plays very nicely with existing JavaScript libraries. You can use them transparently. You can also incrementally type TypeScript. So you can start with any JavaScript you have, and the TypeScript compiler will accept that. You start gradually adding types, and the TypeScript compiler will start gradually, essentially telling you where your code is broken. You fill in the types. We've actually gotten to the point where our entire code base is essentially, our entire front-end code base is essentially statically typed. But that just deals with the front end. One thing that we love about Yesod on the back end is the type-safe routing and persistent, which also gives very strict statically typed models. So a little bit of I'll talk about the models a little bit. In case you're not familiar with persistent, it's a embedded language, and there's a persistent quasi-quoter, and it defines Haskell records for all the documents in your database. It works transparently across Mongo, Postgres, other systems. Make sure all of your accesses are statically typed and safe. So, do we want to directly translate that into TypeScript? We looked at it initially, having the persistent quasi-quoter actually generate TypeScript models so that we can type check our TypeScript code against what we would expect from the server. That actually didn't work out very well. Persistent models how data is stored in the database, but often that's not how data is sent to the client. As a simple example, you might have many fields on your user model in the database, such as permissions. Are they verified? Do they verify the email address? That you don't necessarily want to send to the client. The client might just have the user ID, for example. So we ended up not using any direct link between persistence and TypeScript at all. And we define our TypeScript types from the model separately in a separate models.ts file. Quick call out to Tipson, which we use to help us validate that the objects we're getting from the server at least match the types in the models.TypeScript file. One thing to remember about TypeScript, it's all run at compile time. There's no runtime checking. TypeScript generates plain old JavaScript. There's no type checks at compile time, at runtime. Routing is a slightly different story. So Yesod gives you these great static URL generators. Some examples on the next page. I don't know if you can see them. Yeah, you can't see the screenshot. I'm sorry about that. Essentially what the TypeScript routing system does is it gives you these static guarantees that any URLs you generate, they're not simple strings. It's an ADT that represents all the possible URLs in your site. And that ADT is keyed by strings or texts, object IDs, model IDs from persistent numbers, ints, etc. And that makes sure that you never have a broken URL that you generate in Haskell. But the problem is, we're now in a world of single page apps. Our app does not go from one HTML page to another like a traditional website. Now, in AngularJS, we're simply rendering templates or partials that we get from the server, and we're navigating between them. What that means is that JavaScript now has to generate URLs. This problem is, these beautiful static URLs, how do we generate them in JavaScript? How do we get the same level of safety that we would have generating URLs in TypeScript? We have a tool internally, Yesod routes TypeScript. It's a little hard to see the code, a little hard to see the sample code that it generates. But to make a long story short, what this does is it takes the Yesod routes embedded language, the Yesod routes DSL, the same parser that Yesod uses to generate the Haskell route functions, you see read image R, will generate TypeScript functions to generate URLs. Now, they're just going to end up as strings. We only have so much control over how JavaScript works and working with JavaScript libraries. But at least we know that any calls we make to generate a URL will have the correct arguments and they'll be correctly typed. In this case, you'll notice docfile ID, which in persistent is a separate type. It's a ID for a doc file record in the database. We just treat that as a string in JavaScript. It's something we could possibly extend, but for now, at least we have the right number of arguments, strings versus integers, are correctly being checked by TypeScript. So this is a quick overview of just something that we're doing in docs that I thought might be a little unusual, or at least different from some of the other experience talks. Just to second what everybody else has said, we've been using Haskell pretty much from the start. I've been using Haskell myself for years. I started at Jane Street. For us, it's been invaluable. As a young startup that's pivoting and iterating, we've had to make some really massive changes involving migrating lots of code, lots of data in our database, and it just horrifies me to think if I had to do that in something like Node.js or Ruby, anything like that. I have the URL for these slides that I honestly spent 20 minutes on, so don't feel like they're that amazing. It's actually hosted on our site. I'll email these out if anyone tells me where to email them, and you can find me on Twitter. Huh?
I'll tell you.
All right, great. So that's our quick experience report from Docs.
All right, we're going to get Tim Sears from Pingwell set up here.
Yes.